since the local dev machine is likely not compatible with the required running environment of the code. For example, an old macOS against the latest version of PyTorch, our first strategy would be to create a Podman image, which enables us to move the execution into a Linux container. By doing so, this allows us to bypass the limitation while allowing us to continue using our preferred text editor on our local machine. To set this up, we will construct a container file based on Ubuntu. This file will install Python, curl, and the UV package manager. By mapping our local project directory to a directory inside the container, any code we write locally will instantly reflect inside the Ubuntu environment where PyTorch is fully supported. Here is the contents of the container file. We start with from Ubuntu 24.04 as the base image. We set two environment variables. The first is Debian front end, set to non-interactive, so installations do not prompt us. The second is Python unbuffered, set to 1 for immediate output. The run command installs Python 3, pip, curl, and git, then cleans up the app cache. Next, we install UV by piping the official install script from astral.sh into the shell. We add UV to the path, set the working directory to /workspace, and default the container to launch a bash shell. To bring this environment to life, we will first need to build the image using Podman. Open the terminal in the directory where we save the file and execute the build command. Podman build with the tag flag Ubuntu, PyTorch, dev, and the file flag pointing to the container file. This compiles the image and tags it as Ubuntu, PyTorch, dev for easy reference. Once the image is compiled, we can launch an interactive shell inside the container. The crucial part of the following command is the volume mount flag, which binds our current working directory on our Mac or local machine to the /workspace folder inside the container. This allows us to edit files using our usual local setup while running the code securely within Ubuntu. The run command uses podman run with the interactive and remove flags, followed by the volume mount binding the current directory to /workspace and the image name Ubuntu PyTorch dev. After executing that run command, our terminal will drop us into the bash shell of the Ubuntu container. From there, we can safely develop the project, including successfully running UV, AddNetworkX, sentence transformers, and Torch without running into any platform compatibility errors. If we are on a network that requires an HTTP proxy to reach the outside world, like a corporate network or a strict VPN, we would need some extra configurations to make things work. At the time of this video creation, there is a known bug in the HTTPX library, which Sentence Transformers uses under the hood to download models from the Hugging Face hub. When Podman launches our Ubuntu container, it automatically inherits proxy environment variables like HTTP_proxy, HTTPS_proxy, and no_proxy from our macOS host. macOS commonly populates no_proxy with values containing IPv6 loopbacks like ::1 or local domains. A bug in HTTPX causes it to choke when parsing the colons in these inherited proxy strings, mistakenly interpreting them as malformed port numbers, and will thus throw the invalid port : error at runtime. We bypass no_proxy using the env command exclusively for our program. The command is env-u no_proxy -u no_proxy in uppercase, followed by uv run python main.py. The -u flag unsets the specified environment variable for the duration of that single command, so no_proxy is temporarily removed from the environment before our script executes. With this configuration, we shall be able to successfully download the all-mini LML6 v2 weights to the container's local cache and execute our graph retrieval logic without the HTTPX parsing error.